Hi guys, we're in chapter 3 still, and we're starting section 4 in our textbook, which is what this video correlates with. And the essential question in this video is, how does a linear pattern grow? So we've been talking a little bit about what it means to be linear versus nonlinear. And really, when you start talking about linear, the first thing that comes to my head is just thinking about its growth. And there's always a pattern to it. So we're really going to work on that today in this video. And to make things easier, I'm going to switch screens. Okay, so to get us kind of going here, we're going to approach this linear growth looking at it through different lenses, the different representations. And one of those ways is to start with an equation. So we're going to write equation. So go ahead and write that in your notes. And to kind of get us started, let's imagine we were given the equation. Somebody comes and tells us what the equation is. And this time we're going to have y equals 3x plus 4. Y equals 3x plus 4. Now, if that's all I know is the equation, there's a lot I can do with that. I can easily make a table, I can make a graph, and I can figure out a pattern that would work with this too. So that's exactly what I'm going to do. I'm going to go to the next step here, and I'm going to make a table. And in my table, I've got two variables to focus on. I have x and y. So I'm going to make my table an XY table. And I think I'll go this way with my table organization. So what we're going to do is we're going to set this table up, but we're going to have to kind of come up with the numbers on our own. So we have to do a little bit of work for this first part. Now the numbers I like to put in my table is I like to stick close to 0 because eventually I'm going to be graphing and I don't want to go way out to large numbers. So I kind of like to imagine like if 0 was in the middle, I could do -1 and -2, and I could do +1 and +2, and that would be enough numbers for me to graph comfortably. So that's going to be my setup there. Then my next step is instead of actually having to do the calculation, like what I mean by that is I could take the number 2 for x and put it here and do the math. 3 times 2 plus 4. 3 times 2 is 6. Plus 4 is 10. So the answer for this part of the table is going to be 10. But I don't have to do my math that way. There's another way I could go about it. And the other way is I could look at my mx plus b. My m is 3. That's my growth number, which we've been talking about in some of these prior videos. And my b, my figure 0, is 4. That's my b value. And really, actually, the most important piece of that is that b value helps me know where to start. That means that figure 0, where x is equal to 0, will be 4. What this also tells me is my growth is 3. So the pattern in my table is it's supposed to be adding 3 as I go up. So 4 plus 3 would be 7. And if I added 3 again, 7 plus 3 is 10. So that looks like it matches up. It makes sense. Well, let's do the same thing just going back 3, back 3. So 4 take away 3 would be 1. And then take another 3 away would be -2. And you can see, like, the big connection here, I hope you can see, is that that b value is right here. This is how we got things started, is that 0, 4. And then that m value, that growth, is that growth in the table at the bottom. So here we go. We got our equation. We got our table. We're going to go to the next step, which is to make our graph. So I'm going to write graph. Now before I set up my graph, I'm going to take a close look at my numbers. I notice they have to get all the way up to 10, so I know I'm going to need a little bit of space. So I'm going to grab my ruler here. And my plan is to set up kind of a long y-axis so I can reach 10. So I'll draw a nice long y-axis. Here's my y. To help myself out, I'm going to mark it up here as I want to get up to 10, because that was the biggest number in the y's. So I'm going to go 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. That's going to be where I put my x-axis. In that direction. There we go. And then I know good graphs have labels, so I need to get in here and scale each number. So 1, 2, 3, -1, -2, -3. I gotta do the same thing going up. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And here's -1 down at the bottom. Kind of ran out of room. Maybe I should extend this just a little bit more so I can fit -2 and -3 on here. There we go. Okay, cool. The graph is set up. Let's plot some points and put the graph together. So my points start at -2, -2. So I'm going to go -2. I'm going to go down to -2. I'm going to put a solid point right there. Then I'm going to go to -1, +1. So go to -1, up to 1. There's my point. Then we're going to go to 0, 4. So 0, 4, which is right here. And then 1, 7. So 1 up to 7. And the last but not least is 2, 10. So 2 and 10 way up here. And sure enough, just like we expected, it looks like a line. And I knew in my head it was going to be a line. I knew it because way back at the start, it was y equals mx plus b. That's how I knew it was going to be a line. Then in my table, when I saw it went +3, +3, +3, +3, and the growth was constant, then I really knew it was going to be a line. So this does not surprise me. So I'm going to connect my line together now. I'm going to take these points, line them up with my ruler. I'm going to extend a line that goes all the way through them and draw arrows on it. And then next to one of the arrows, maybe the bottom one down here, I'm going to write the equation. Y equals 3x plus 4. Now, awesome. Now the graph looks pretty good. I also think I'm going to circle right here at 4 because that was my b value in my y equals mx plus b. This is what we call the y-intercept. It's the y-intercept because it's intercepting the y-axis. It's hitting it right here on the y-axis. So we call that the y-intercept. Now if I really wanted to get into it right there on the x-axis, we call that the x-intercept. But I'm not really worrying about the x-intercept right now. I'm more concerned about the y because that's my b value. Okay, so we've got 3 out of the 4 representations. We have the equation, we have the table, and we have the graph. Only thing missing is we don't have like a story problem, like we don't have a real life connection to what we're doing yet, or at least a pattern that we are studying. So that's the 4th representation that we are kind of missing at the moment. So I think at the bottom down here, we're going to add that representation. No, we're probably not going to make up a story problem for this one, but we could draw a pattern. We could represent this linear pattern visually. And in my pattern, to have a pattern, you have to have at least 3 pictures. So I'm going to label them figure 0. We're going to draw a picture of figure 0. Then we're going to draw a picture of figure 1. And then we're going to draw a picture of figure 2. And you could keep going. You could do figure 3, 4, and 5 if you felt like it. But here's the thing you have to remember. The table numbers tell us what we're doing for a pattern. So figure 0 has to have 4 tiles. Figure 1 has to have 7. Figure 2 has to have 10. So it's got to be 4, 7, and 10. So when I go to figure 0 here, I'm thinking in my mind like, okay, I'm going to use my graph paper. I'm going to break it up into 1, 2, 3, 4 little boxes. That's my figure 0 has 4 boxes. Or in class, I like to call them tiles. They look like tiles you do in the bathroom floor or in the kitchen. So 4 tiles. Now I have to grow and add on 3 to make it 7. So here's that 4 again. Same 4 as the last picture. But now it's my job to add on 3. So I think I'm going to add my 3 to the side here. I'm going to go 1 and 2 and 3. Now there are 7 tiles in my picture. I have added 3 extras on. I'm going to go again. I'm going to add on 3 more because I know the growth is 3 and I should have, figure 2 should have 10 tiles. So let's see here. I'm going to draw the original figure, which I'm going to put really close to this, I think. So here's figure 1 with the 7. But now I need to add on 3 more. So 1, 2, 3. There's figure 2. And that should be 2, 4, 6, 8, 10 boxes, 10 tiles. A little 10 under here. And there it is. That's my pattern. I've got a picture to represent what's going on here. Now all 4 representations are involved. So going back through, we got the equation. That's one way to represent a linear pattern. We've got the table. That's a second way to do it. We've got the graph. That's a third way of doing it. And then the 4th way is we either find a real life story or we show it visually with a pattern. And that's kind of our fourth approach to this, another way of going about it. So let's go back up to the top of here, and for your notes, let's label this example 1. Since we didn't do that at the start. And now let's try a second problem. We're going to do another example with a different equation. Let's do an example 2. I'm going to write example 2. New equation, but similar idea. We're going to work with this equation. So equation. I want to work with y equals negative 2x plus 5. Negative 2x plus 5. This one's different because we put a negative in there. So I want to work with that negative a little bit. I can see, like, here's my m for mx plus b. I can see here's my b. So I've got my growth and I've got my figure 0. And what we're going to do is we're going to set up a table based on those two numbers. So now it's time for the table. And when I go to set up my table, this time I'm going to set up my XY table. I think I'm going to go vertical. Doesn't matter which way you do your table, so this time I'm going this direction. And in my table, I stick to those same numbers. I'm really like a creature of habit when it comes to graphing. So I'm going to do negative 2, negative 1, 0, 1, and 2. Those numbers tend to be my easiest ones for graphing. But what I know is I know what figure 0 is. B is equal to 5. So right here in the table, I already know is going to be a 5. That's the B value. My growth is negative 2. So what is my growth doing? It's taking 2 away. It's not actually growing. It's kind of shrinking. So 5 take away 2 is 3. And if I take 2 away again, I'd have 1. Now, if I had to go backwards, I'll have to add 2. It'd have to be 5 plus 2 is 7, plus 2 is 9. And there's my table, 9, 7, 5, 3, 1. Okay, well, now that I got a table and an equation, let's move into the graph. So now down below, we do our graph. Now the graph's got to reach up to 9, so it's probably going to be pretty close and similar to the size of the last graph that we did. It's got to get pretty far up there. So I'm going to take my ruler and draw a pretty lengthy y-axis. There we go. This time making sure I get up to 9. So 8, 7, 6, 5, 4, 3, 2, 1, 0. There's my x-axis. There's a lot of people in class that will always make their graphs the exact same size every time. And if you do that, it doesn't always work out. You got to reach these high numbers sometimes. So anyways, let's put a scale on here. 1, 2, 3, 4, negative 1, negative 2, negative 3. And same thing going up. 1, 2, 3, 4, 5, 6, 7, 8, 9. And going down, negative 1, negative 2. Okay, all right, let's plot some points. So going to our table up here, it looks like our first point is at negative 2 and 9. So I'm going to go to negative 2 down here, and I'm going to go up to 9 and plot a point. Then the next one looks like it's at negative 1 and 7, so negative 1 and 7. And then 0, 5, that's our B value. 1, 3, and 2, 1. And just like expected, it looks like a line. If you take your ruler, those points should perfectly line up. And they do. They do if you did it correctly. So I'm going to connect my points. I'm going to draw my arrow. I'm going to, next to the bottom arrow, write the rule y equals negative 2x plus 5. And I'm going to circle that B value, that y-intercept. I'm going to label it B. And then I'm going to write y-int, which stands for intercept, or it hits the y-axis. And I have a pretty good graph. The only thing missing in this problem right now is I don't have the pattern or the story, so I'm kind of down to that last step again. So I think that's what I'm going to do over here next to the graph. I'm going to draw a pattern. And my pattern only needs 3 pictures, so I'm going to do figure 0, 1, and 2. So I'm going to, right here, we're going to do figure 0. Then we'll do figure 1, and then we'll draw figure 2. And if you look closely at the table, you'll remember our numbers go 5, 3, 1. So figure 0 has to have 5 tiles. So this time for my figure 0, I think I'm going to go, let's do it like this. 1, 2, 3, 4, 5. Just a boring straight row of tiles. But figure 1's got to shrink down to 3 tiles. So now it's just going to be 1, 2, 3. And then figure 2 has to shrink down to 1 tile. And then I'm done. And there's my pattern. Now, if this was on a test or a quiz and you were working on doing the 4 representations, your graph and my graph would need to match and look the same. Your table and my table would need to match and look the same. And our equations would need to be the same too. Those 3 pieces would have to match up. But the pattern could be different. Like you might have still drawn 5, 3, and 1 tiles, but your 5 tiles you could have arranged in a different shape. Your 3 tiles and your 1 tile, well, I guess 1, we all have to draw it the same way, right? But your pattern doesn't have to match how mine looks, but it does have to have the same number of boxes. It has to go from 5 to 3 to 1. So we could have, like in class, if everybody was working on this, everybody could draw it just slightly different than each other, and we'd still all be right. There's no like one way of doing it. So just kind of keep that in mind. Okay guys, I think that's going to be it for this video. We're going to work on this section in our book for a couple of days, but I just hope you're starting to kind of get in your head the 4 representations that you can write an equation, that you can make a table, that you can draw a graph, and you can draw a pattern so we can see it in many different ways. Thanks for listening guys, and I'll see you next time.